Good afternoon, everyone. Thank you for coming to this talk. Today I'm going to talk to you about new machine learning services with Python inside of SQL Server 2017. So most of my talk is going to be demos. I'll set up the context with a few slides in the beginning, and then it's mostly demos. I'll start from literally from Hello World, and then show a deep learning application running inside SQL Server. First, show of hands. How many of you are familiar with SQL Server R services? Couple? OK. Did anyone of you attend Joseph Sirosh's talk yesterday? All right. OK, couple. All right. So here's the recent survey from KD Nuggets about the most popular software and tools for data science. If you look at it, of course, R and Python and SQL, these are the top 3 ones. And among them, Python seems to be the most fastest growing one. So in 2016, we brought R inside SQL Server for you to be able to do in-database advanced analytics. And now, in 2017, we are bringing Python in SQL Server 2017 as well, so that now you can build and deploy advanced analytics and machine learning applications using Python also. And I'll talk about why that helps in a bit. The other thing that is happening in the Python world is there is a lot of momentum around machine learning and deep learning especially. So all the new deep learning frameworks like TensorFlow, Keras, Theano, Chainer, Microsoft's cognitive toolkit, you name it. Everything has Python bindings. So with this integration, now you can bring the latest and greatest of the open source innovation for machine learning and make it work on the data that you have in SQL Server. So the data remains securely in SQL Server, but yet you're able to take advantage of the latest and greatest framework. So let's quickly see, OK, Python is great. What do I gain by bringing Python in SQL Server? The biggest advantage is elimination of data movement. So typically, the machine learning systems work with a team of data scientists, and then data scientists work with a bunch of data. They iterate, they build models, and then they hand it over to somebody who then deploys that model into production to get intelligence in their applications. All of that process involves a lot of data movement. Oftentimes, that is just not possible to move the big volumes of data that is needed to produce good quality model. There are security and compliance and governance issues with data movement. All of that is eliminated by bringing compute to data instead of taking data to wherever you're doing compute. That's a huge, huge, huge advantage of doing this. The other thing is that once you have the model, let's say using whatever means your data scientist team had everything that they needed, and they built a beautiful model, how do you then put into production where the LOB applications, your business applications, your users' applications are able to access it? So we worked with a customer who told us the story where they would get fragments of data from their IT team, and the data would be sort of outdated, and then they would have to do a lot of stitching together of data. And then finally, they would build the model. They would give the model back to the IT team. The IT team would then literally translate those models that were written in R into Java code. And it used to take them months. And by the time the model was deployed in production, and it looked very different. The fidelity was not the same. Data had changed by the time. So there was a lot of pain. So when we worked with them and they brought their sort of R-based models inside of SQL Server, all of that 6-month process was reduced in a couple of days. So that's a huge advantage. Now you can do that with Python, right? And the third thing is you gain a lot of performance advantage, using which you can literally do the enterprise-grade machine learning type applications. There are sort of 2 aspects to it, right? One is the innovations inside of SQL Server itself, like the in-memory querying capability, like the column store indices. You take that and you combine with a bunch of algorithms that Microsoft is building. We have a package called RevoScale Pi, which includes the scalable and parallel version of a lot of common machine learning algorithms like logistic regression, trees, and so on. So you combine those two things, and you get literally enterprise-grade performance and scale. So let's take a look at some of the scenarios where this thing helps. Right? The first one is the data scientist scenario. The package that I was talking about, RevoScale Pi, one of the things it does is it has a concept of, in addition to having parallel and scalable algorithms, it has a concept of remote compute context and data sources. So while you're still working in your IDE, you can execute the Python code to run in SQL Server on the entire data set. You're not bringing data to your IDE. You're still typing code and executing it in the IDE, but the execution actually happens in the box here, and the results are brought back to you. So you're no longer limited as a data scientist. You're no longer limited to work with samples of data. You can work with the entire data sets, right? So that creates sort of a lot of advantages for a data scientist. Now, here's the developer scenario, right? So your data scientist team gave you the model, and that story that I told you about them having to recode the entire thing from R and Python that they didn't know into Java or C# or whatever other language they are using for application. Now what happens is that model gets deployed in SQL Server as a T-SQL stored procedure that embeds the Python code. And the application is just making a stored procedure call, and they don't even have to be aware that there is Python code running inside. And the execution happens on SQL Server, and the results are returned back to the application, whether it's plots, whether it's prediction scores, whatever, right? So that operationalization becomes as simple as making a stored procedure call. And the best thing is, the existing apps that have always been talking to SQL Server for data, regular queries, can now become smarter using this model, right? There is a third thing about sort of with this integration. SQL Server is owned by the DBOs, right, the database administrator. So we have built in a lot of mechanism to make sure that the administrators can govern it properly. They can control it, control the access to this. This runtime can have access to only the amount of resources that the DBO allows. So we have built in a lot of mechanisms for that. There are a lot of management views that we have created so that the DBOs can still have full control of what gets executed on their machine. So here's a quick sort of high-level view of the architecture. So there is a special system stored procedure that we have created called SP execute external script. I'll show that more in code. And now, in addition to R, it also takes Python as a language. When the execution comes to SQL Server process, it just basically passes it to an external launchpad process, which then invokes the right runtime, whether Python or R. And then this process runs in a low privilege user, under low privilege user account that we create, only on the box, local account. And then there is a high throughput data channel for communication between the two processes. So that's the overall sort of high-level diagram. So let's jump to some code. OK, so here's my simple hello world in Python running in my IDE. I get the result called hello world. Let me show how do I just take this code and make it run inside T-SQL, right, in SQL Server. So I take that hello world code. This is a regular looking T-SQL script. I have this SP execute external script that takes a language and a script. Language as Python, and it takes a script, which is just plain Python code. And if I execute it here, it's running in SQL Server, and I get the exact same results. OK? So now this is just basic, simple, taking a code that was running outside and bringing it, but that doesn't show any of the sort of the deep integration that we have done. So let's take a look at that. Come on. So here is, again, simple script. I have a temporary SQL table called Python test. It has just 2 columns. Here's a simple schema. It has day of week and some value, right? Sorry. Somehow my scrolling is not happening properly. So now I will take that table and I will manipulate that table. I will change the days of week to a numeric value using a Python script. And what I'll pass to that Python script is an input data set, which is this query. I can just pass the results of this query. And I can pass a number of parameters, like input parameters and output parameters. And I can pass something called rows per read that I'll talk to you about in a minute. So I will take these parameters, and I'll change parameters in Python script, and I'll change the actual table value here. So here's the script. It just prints hello world first, and it takes the parameter and changes the numeric parameter as well as the character parameters. And here's the map, which maps the days of the week to numbers. And this table is then passed to Python as pandas data frame. And then it'll just execute and do that, right? So let me execute this. So what happened is, here's the result. Here's the input table, and here's the output table. It has just changed as expected. And if you look at the results, you're seeing the parameters before and the parameters after are different. Input parameter has changed, and the output parameters have also changed. One of the other things is, I talked about rows per read. What this does is, here. So often you might be working with huge data sets. So even before your SQL query has completed its execution, it can start passing the data to R or Python, and it can start executing in parallel. We call it streaming. So here, if you can see, there are two, the hello world has been printed twice, because there were 10 rows, and I specified rows per read as 5. So it is, as soon as it read, it started passing, right? So if I change it to 10, for example, it'll just do once. Okay, so here it just printed once. Other quick thing that I want to show you is this thing called max DOP. Now this is where the trivial parallelism happens, right? So if the query can be parallelized, and if the Python code can be parallelized, if you specify that, it'll execute that in parallel. So if I execute this, you will see two different processes running. So there's process 1 and process 2, right? And if I can quickly, here's the, so if you see on the right in Process Explorer, you will see two Python processes running under SQL. Okay, so now I talked about bringing external libraries in here. So here's the popular TensorFlow. Now it's in few lines of code. I can just bring in TensorFlow, and I can make it run in SQL as well. And all that I had to do was simple pip install of TensorFlow in the right appropriate path. So here's TensorFlow running inside SQL Server. Now, the scenario that I talked about, where I, as a data scientist, am running from my ID and the execution is happening in SQL Server, is achieved by this package called RevoScalePy. So it has some parallel algorithms like this RxLinMod EX here, which is the logistic regression, linear regression model. But it also has the compute context concept, where the compute is happening on SQL Server, using which. And it has the concept of data source. So here I'm specifying that I want the data source to be SQL Server data. So if I scroll down, here's where I'm specifying the connection string, and I'm specifying the data source to be SQL Server table, and I'm getting the results from SQL Server queries. And I'm saying compute context, it needs to be done inside of SQL Server. And here I'm executing something, doing some linear regression, right? So it's a simple popular airline database thing, and I'm doing some logistic regression on it. If I execute this, it went and it started doing the compute on SQL Server, and it brings back the result. Here is just basically printing the model, the coefficients, etc. Let me show this one more time, that the execution is actually happening in, I don't know why this is slow. Let me execute this again from ID, and you'll see two Python processes running in. Look at this. So this is executing inside SQL Server. I was executing the command from IDE. All right. So that's just the basic sort of mechanism of how we can do basic things here and how the actual integration is done. Let me show you an example of a deep learning app running inside SQL Server. So here's an app that you can find in a radiologist's office. I don't know why it's not displaying this, but there. So I come and search for a patient, and I get the medical history of that patient, and I see the lung scan, CT scan of that patient. And if I hit the Analyze button, there is a deep learning model that's running in the background. It went and analyzed hundreds of images that make up the CT scan, and it did the classification of those images and came back with a prediction that this person has a certain probability of cancer. Right? So these kind of things are very complex to build. Now, so typically, these are the two steps involved, like learning and scoring. Right? So in the learning phase, we took all the images, hundreds of thousands of images, and we used a pre-trained deep neural network that is available, called ResNet 152, and that is available as in Microsoft Cognitive Toolkit. So we didn't have to train this neural net, which is extremely complex to do, and we were able to leverage that to generate features as in the specific properties of those images that are relevant in making a lung cancer determination. And from those features, then we trained a boosted tree algorithm to create a model. And when the model is ready for scoring and the new data comes in, you take those features and apply that model to generate scores, right? So typically, all of these things, the dark blue things, are data and model assets, which are very difficult to move around. And this is usually done by the data scientists, and this is done in the application environment. And there's a lot of pain around that, right? So how do you get the entire data set to work? In our case, though, we didn't have to do any of that. All the data and model assets were in SQL as SQL table, and all the actual Python machine learning code was running in stored procedure as embedded Python code. And this app was just making a simple stored procedure calls. I have a couple minutes left. Let me show you the actual code. So here's the code. I'll not show you the whole thing, but again, it's a regular-looking T-SQL stored procedure, and there's some Python code running in here. This is where I'm doing the featureization, as in generating features from the images. So here, no, this is not that script. Let me use this. So here what I'm doing is, for each patient, I'm getting these scans, and then I'm getting the model, the ResNet 152 model that was stored in SQL Server. And I'm then doing some manipulation of those images to fit in that model. Again, I'm using an open source package called OpenCV for that. And then I'm generating features. But here I'm able to leverage the GPU. So this SQL Server machine is running on a GPU, on a box that has GPUs. And by just giving one command, I'm able to leverage GPU. And we were able to get almost 30x performance boost just by leveraging GPU. So you can now do GPU-based deep learning on SQL. All right? So once the features are generated, we store the features back in a SQL Server table. All these features and models and everything is stored here in these tables. And then we do the training in another stored procedure. Here we are just taking the data, splitting it into a training and measurement set, and then we are training the model. And the third one is the actual prediction score, stored procedure. That is called by my app. Right? So here, the features for the new patient is coming in, and I'm making the prediction using the model that I just stored, and then I write out the scores. Right? So we saw how sort of using the in-DB integration of Python, you can do basic ETL to deep learning application inside of SQL Server. We encourage you to go try. This is in the latest CTP 2.0 release of SQL Server 2017, and give us feedback. My email address is sumit.kumar@microsoft.com. We have started putting out a bunch of samples. You should try that out. And thank you for your time.